totally forgot to record here. I'm gonna have to redo some of that. So we're just looking at special lines at this point here. Okay, now the fun part. Where did the word M come from for the word slope? Because I always thought the word slope starts with an S. That would make sense, right? And so the history of slope. Again?
I bet it's Greek.
Landon, say again.
I bet it's Greek or something. Greek.
Greek. Oh, very close, very close. History of slope. So remember, let's talk about this here. When did the algebra and geometry get fused together? With Descartes. This was what years about? This is about 1600s, or so 1500s is where it happened. So 16th century. So you're talking about 1500s. Greeks already went bye-bye. This was for a little while. Okay, so then it's so interesting too, because in the 1500s, the French took over everything, right? The Renaissance is happening, right? So you have this explosion of knowledge and wealth. So the French mathematicians are getting on the bandwagon as well. So it is French. Oh man, no fun. There it is. So their word for slope is, it's mortar. It's M-A-R-T-O-R. And that means slope. And guess what? Because math is really not letters, they're really symbols, right? And so when they started doing it, when the French started doing it, they started using the letter M. And so we just kind of kept that tradition. So when we moved to the slope-intercept form, we kept the M as a slope because that's the way they wrote it. And B, it was just the piece of the horizontal line. Okay, are we good there? The way I remember it, real quick here, if you're drawing a line, if you really need to, is what you do is you begin with this letter. You good? Because you always begin along the x-axis if you're graphing a line, and then you move according to this one. So it's kind of cool. I like the little acronym there. Okay, so now let's do, since we're looking at parallel perpendicular lines, let's go with one more example. This is still 1.3 finishing up. And you guys talk to me. If I'm going too fast, just say, Mr. G, can you go back real quick here, or anything like that, okay? So you guys have to tell me, which exercise problem are we on from Wednesday?
Exercise 5.
5, okay. Boom, boom, boom. Exercise 5. So find the equation of a line that passes through, I'm writing a little slower, so not to do all the chicken scratch for you guys, that passes through 2, -1, and is to x minus 3y equals 5. Boom, there it is. So we've got to the culmination of this graphing stuff. So we started off graphing just equation to graph. Then we figured out this whole concept of slope. Then we were able to go backwards. We'll go from graph back to equation. And now we're able to interact between two different lines. And the interaction is perpendicular or parallel, just depending on what it says. So I want an equation of a line. Passes through that right there and is perpendicular to that. Ooh, okay. So as soon as you hear find the equation of a line, which formula comes to mind? I need the equation of a line.
One of these formulas.
One of those formulas, yes. Abe is totally correct. One of the formulas.
The y2 minus y1.
No.
It's the
Y minus y1.
Yes. Perfect. Yeah. As soon as we heard the word equation, in your mind, you automatically say, oh, it's this formula here because that formula gives me the equation. That's right. And then it says that passes through. Oh, cool. It passes through 2, -1. So do I know something? Yeah, I know my x1 and I know my y1 right there, right? Okay, I am missing something here. So I can probably put this in. Let's actually put this in. So this can be y. Everybody okay with putting a +1 in there already? Because it's a -1 coming through here. So subtracting a -1 is adding a 1. Oh, that's what I'm missing right here. M is missing. So this is x minus 2.
And you can figure out because if it's perpendicular to that other thing, then if you put that in the slope, it ends up you have the slope and then you have the negative reciprocal.
Perfecto. Couldn't have said it better myself. So let's do this here. We're trying to get the perpendicular to this guy. This guy is going to give us our M. Our M is going to come from that guy. We're good? Now, because it's perpendicular, we might have to do a little bit of funny work with it, right? Something about negative reciprocal. But let's put this into slope-intercept forms first, right? So in my mind, I'm thinking this form right here, like this, and I'm thinking of getting that little guy right there. So it's Isabel, and Isabel was correct. So let's go with it here. So can you solve by yourself? Can you solve this guy for y? It'll be a funny looking fraction, but I think you should be able to do it. All yours. Give you guys a whole bunch of time, like 17 seconds. So solve for y, whatever you need to solve for y. Owen just finished it in his head. And the answer is, okay, let me start. So I'm going to subtract 2x from both sides. That cancels. I'm left with -3y is equal to, and I like to put the one to x first. We good? Because that's my form. My form is y is equal to something with x plus some weird b at the end. All right, what should we do? Divide by -3 is perfecto. -3 here. And what I like to do sometimes if I'm having to divide multiple things, I divide them individually because that's a lot easier. Then put a big line across the bottom, then -3, then think, oh, that's right, I got to do both of them. So I've solved it for y. I got what I need here. This is going to be negatives are destroyed. So I left with +2/3, and I'm left with, oh, 3 does not go to 5, huh? So I'm left with 5/3. I don't care about this guy because which one's the only thing I care about? The slope. I'm caring about this guy. So if it said it was parallel to this guy, I would use 2/3. Because it says perpendicular, what is the slope that I want?
M minus the -1.
Yeah, so it's a negative reciprocal. Can we do that? So if it was a negative already, I should say opposite reciprocal because it's opposite sign and then reciprocal answer. So what's the opposite reciprocal of 2/3? I go with -3/2, right? Positive 2/3, opposite would be a negative, right? And then the reciprocal just means you flip over the top and bottom. So negative 3/2. Okay, I got what I need. Let me plug it in. Y plus 1 is equal to -3/2 x minus 2. Your job, if you choose to accept it, is to solve for y on this guy. Can you solve this guy for y? And I'll play Jeopardy. Dun, 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 dun. Dun, 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 dun. You're gonna have to distribute the little fraction inside there. Should be still okay. All right, let me try it as well here. So y plus 1 is equal to, I'm going to distribute this guy, negative 3 halves x. Then I'm going to distribute here to here. Oh, so that's negative 3 over 2 multiplying a negative 2. I put a little 1 underneath it. All right, negative times a negative, positive. Dun, dun, dun. How about 2's and 2's? Where do they go? They cancel out. Yep. Boom. So plus 3 at the end over here. Subtracting 1, subtracting 1. Negative 3 halves x plus 2 is our final answer, and there it is. We've created a perpendicular line. It hits this first line right at a 90-degree angle, but it goes through the 0.2 negative 1. Are we good? Okay, let's see what we got here. I think we probably should do that. Yeah, let's see. I think so. Okay. You guys have calculators, actually, out of curiosity. Okay. Okay, let's do some problems here that will involve sort of slope and all those different things here, and more real life sort of things here. So maybe a first one would be, let's do construction first. Boom, boom, boom. Exercise 6. I'm just going to put this as solve the problem. We'll get some few problems here. So construction first, and then we'll move on from maybe to taxes, maybe. I don't know. We'll see. So taxes. We got to do taxes here.
Oh, I can hire someone else to do taxes.
So can you real quick do the sum? Can you do 1 divided by 12 times 100? So I don't want to know what that is. Okay. 1 divided by 12.
Sliding the case on and sliding it back off is going to turn it on.
Okay. 1 divided by 12? And then multiply that by 100. 25? Oh, hold on. I just need a decimal approximation. 8.3%? 3.3, okay. So 8 and a...
There's probably a setting to give you fractions.
Yeah, it's a fraction. Let me see your calculator. Let's see what it looks like. Boom. You have this little, like a triangle, filled in triangle. Not a triangle, sorry. Filled in right here on this side. You have this little, what is it called? A diamond, sorry, yeah. Yeah, click on the diamond and then click enter. And should give you approximation.
What does it look like again?
Yeah, it's a diamond shape like this, little button. So Dylan, let me see your calculator. Let's see. Flip the back side of it here. TI something something. Okay. You're probably. Yeah, no problem. We'll do it as a class because not everybody has a calculator. So let's go for it here. So real quick here. You guys ready? You don't need a calculator just as long as a couple of people have a calculator to check our work here. And then I'll check if you guys want to do it with calculator. I will help you guys to get the answer that you need. Ready? On your mark, get set, go. So a ramp called wheelchair access to things here. In order to have wheelchair access, I believe it's 8 and a, well, it says, according to the book, it says 8 and a third percent, but I think it's actually 7%. I'm going to go with 7. I'm going to change it up. I believe the California code is in order for you to have wheelchair access, the ramp that has to be there, the steepness has to be less than 7% steepness on a ramp. That's the way it works. And so we had maybe like 20 years ago, there was a flurry of lawsuits because people build out these ramps, right? And there was an attorney, or attorneys in different cities, right? They would file lawsuits against companies that didn't have the proper steepness on it. Right? Board, absolutely. And it was just this crazy thing that, I mean, hundreds and hundreds of cases. Could you imagine every small business? So then every small business had to go and actually measure out the height as well as this to make sure they conform. And if not, then you had a construction company that had to take off the old one, right, and put in a new ramp according to regulations and stuff. So that was a huge, huge thing. All right, so let's go with it. Our ramp. I have a ramp that's next to my business, and it is this. And I measured it, and it was 22 inches high, and it's 24 feet. So inches to feet here. And so there's my little ramp that I looked at. I could do that, right? I could walk outside. I can measure down real quick here. That has a certain elevation, right? And then I look at the distance of my ramp. And so that's what I got right there. Now the only question for you guys is, did it conform to the law of 7% or not?
7% of what?
It's just 7%. The steepness has to be 7%.
How do you have a percentage if you don't know what the percentage is of?
I got it. So what is a percent? Percent is, go back to our 7th and 8th grade days, right? We have a decimal, a fraction, and percent. They all pretty much the same, right? Decimal, fraction, percent. So percent is just something over something, right? And you have a percentage of that. So 1/2 is 0.5, which is 50%. Are we good? There we go. If you want to convert it to decimals, Owen wants to convert to decimals, 0.7. That's cool. 0.07. Sorry, that's 70%. Okay, cool. We can convert to decimals because decimals, percents, fractions are all the same thing. Okay, talk to me, everybody. Talk to me. What's the slope has to be? Slope of the ramp has to be less than 7%. So how the slope of ramp? Oh, that's cool. Okay, Abe says something about a squared plus b squared equals c squared, but we're not measuring the length there. We don't care about the length. We just care about how high it goes versus how long the distance is to go. 22 inches height and 24 feet back.
So if we convert it 20 feet to inches, then you say just like the X
That's cool. Okay, I got it. So boom, boom, boom. Rise over run is our slope. We got that. Good. Could be.
It's 288 inches.
Oh, yes. Okay, so cool. So we have to get the same exact unit values, right? Because you can't compare inches to feet, feet to inches here. So multiply this by 12. Landon, what'd you get?
288.
288. That's cool. Okay, I got that. I think we're ready. What's my rise?
Right?
22. Awesome. I go with that here. 22. And run. 288. Notice the inches go away. That's exactly what happens in physics and chemistry. As long as your units work out, then the rest of it is going to work out well. Boom. What do we have here? So someone with a calculator. Unless you want to do it by hand, that's fine too.
It's 12.1 something.
I should be less than 12. It should be less than 10 because I have a 22 on top, but I have a 288 on the bottom, so it should be less than 10.
Yeah, I got 0.076388.
Okay. 0.07.
Oh, I divided the wrong number by the wrong number.
It's not over.
It's technically too close, right? It's over that 7.
Too steep, yeah. So here it is. We got a 0.076, and we got ourselves a problem. And we don't need to go further than that because we know we are done at this point, right? So this converts to 7.6%. We're above the 7, And now we got to hire a construction company come in, destroy that, and make it a little different
Dude,
here.
that's
Good.
so stupid.
Hey,
That's
you're
so
not in a wheelchair.
Yeah, or am I?
Hey.
No, you're not. Not yet.
Okay, one more.
Between and and should be.
One more.
I feel like I was gonna like eat it one day while he was walking down the street.
Let's go with
I'm crazy.
B. It will just be B. This is example 6A. This is example 6B. We've got 5.5 minutes left. Let's go with it here. So something about taxes here. I guess we should do this here. So we buy.
Oh, we're actually learning about something.
Now we buy $12,000 here. We buy or lease a car. All right, let's go with it here. How about we buy a car for $22,000? Nice.
Whoa, that's expensive.
And we depreciate
I don't like depreciation.
it by, and we're going to take,
What is it? What is it? Buy a car?
yeah, we buy a car for $22,000 and we depreciate it for tax purposes by $5,000 a year. Good?
That's a lot of depreciation.
And so here's what happens with taxes that are not normal. A car depreciates a lot faster when it's off the lot, right? It goes like this. It goes vroom. It depreciates from one year to the next. It depreciates a lot, and eventually it
That's why you don't buy a
depreciates
new
slower and
car.
slower. That's the name of the game. Usually, is you buy maybe a 3 or 4 year old car. Therefore, you pass this little piece right here, and now you're at least when you sell the car, it's not as fast depreciated. That's
Pay it up front.
or paid up front. So for tax purposes, though, here's a little problem. Whenever you buy something that's for a business, we don't depreciate it according to the table. You don't say like, how much is this car worth here? What you do is you just depreciate it according to a linear slope. And so you say, look, I'm going to take $500 off or $5,000 off each year for the next so many years. Right? Oh, you know what? I wrote it wrong here. So we depreciated by, as I was thinking about the value here. Sorry, guys. Can I redo it real quick here? With those with pins. Really sorry about that. Let's see. We depreciated for, let's see, for 4 years. Just make it simple here. We're going to take it. We'll buy the car. We're going to get another one in 4 years. So we're going to depreciate this one for 4 years. Sorry, guys. Let me. We're almost out of time here. So, what is the depreciation value per year? And so, what tends to happen is that we do this right here. We say to ourselves, "Look, we started off at $22,000 on the car. We got 4 years later. We're going to be at 0. So this is 4 comma 0. This is 22, 0 comma 22. And it's a slope function. That's all it is. We take $22,000, subtract it from the 0 value, which is all the way down here. We good? So 4 years, it should be fully depreciated. And then we go on top, we go 0 minus the 4 that's over here. And our slope formula is actually how much we can take off our taxes each year. So I got myself $22,000 divided by -4. Anybody with that figure anywhere?
Yeah.
500. Perfect. Okay. Okay. So we can take off, or we can write off. Per year, right? It is per year. Okay, how are we good there? Now we're finished with 1.3. At least that gives you a little bit of a, was that pretty cool? I think that was kind of cool. A few things here. All right, you guys have a good weekend. I will see you guys on Monday. And if you want to give me your test corrections now so you don't lose them somewhere, please do now. Thank you so much. Thank you, Abe, so much. Have a good weekend. Thanks.
I'll be right back.
Sure, you got it. Bye, Phil. Have a good weekend. Bye, Maddie. Bye, Ned. Bye, Landon. Have a good weekend.
So I was going through my notes and forgot that I didn't actually pack it.
Yeah.
So if you want to go over like what you found with those two together, I would greatly appreciate that.
Yep, and Dylan, if you want here, I got it right now. It's this one right here. It's the that should have been a 15. That was the issue. So
Actually,
it's the 14 plus 1
I see.
instead of subtracting 1.
Okay. And what about 19?
19.
19, I went over with my tutor. He said he couldn't find why it was marked off.
Okay, this one. 3. Okay, so we're good here. If it was like this right here, you know, if you were just simplifying these two together, that would have been fine. But what you're doing is you're solving it. So here you're gonna still have an equal 1 on your hands, right? And you're gonna have to solve it out.
I see.
So you did simplification on the left-hand side. That's what you did right here,
I see.
as opposed to solving.
I see.
So what you want to do is you want to multiply by common denominator everywhere, and then go from there. And I have, it should look something like this right here. So we're multiplying through here by each of the common denominators. And what you eventually get is you get this right here, and then those two are multiplying this side right here. This is multiplying that 1.
I see.
Okay, you good there?
Yes.
Does that make sense? Okay, and then this one.
Yeah, I already solved. We found out.
Okay, perfect. And you got the same answer as me? That's cool. Okay, are we good there?
Yeah.
So if you want to correct this guy to 15,
Okay.
and then from there, push it. This one does need some work involved in solving.
Okay.
Cool. I'm so glad we solved it. Are you feeling better now about that? Now that you got
Yes.
the answers?
Could you still like send those to me?
Oh, sure. Yeah. As far as the corrections for it, right? As far as like this right here?
Yeah, like what you found.
Yeah, 18 and 19, right? Okay, yeah, sure. No, absolutely. Yeah, send it by email.
Thank you.
Try to do it today, okay?
Okay.
Hopefully I don't get mixed up again. Okay, I'm gonna let you guys go so you get to the next class here.
I don't have the class.
Oh, okay, that's fine. Kristen.
This is Dylan in work. Pretty else.
Okay, And does he have his test itself though?
I don't.
I need the test itself though, because I regrade him.